Okay, I'm going to go over another technique on how to find zeros of a quadratic function. And I want you to be able to solve quadratic equations by completing the square and write quadratic equations in vertex form. So sometimes quadratic equations cannot be factored easily. And for these types of equations, you can use square roots to find the roots. So the square root property basically says that you can, if you have a squared, say an x squared equals 15, then the absolute value of x equals the square root of 15. So that means x is going to be a positive or a negative square root of 15. Okay, let's try an example here. The first thing that we're going to do is get x squared by itself. So we need to add 20 to both sides. And this has a 4 in front of the, or as a coefficient of the x squared term, so we'll deal with that in just a second. But again, move the 20 over to the right-hand side, and that will give us 4x squared equals 25. And we can divide both sides by 4. And when we divide both sides by 4, we're going to end up with x squared equals 25 over 4. We're going to take the square root of both sides, and when we take the square root of x of this side right here, we could just split the square roots up, square root of the numerator, square root of the denominator, and that's going to give us x equals plus or minus. Now remember, you need to write plus or minus because of the square root property. So let me ask you this, just off to the side here. If I have x squared equals 4, and we want to know the value of x that will make this true, well, we can square 2 and end up with 4, but we can also square negative 2 and end up with 4. That's why you need to do the plus or minus there. Okay, there's one for you to try next to it. All right, if a quadratic expression of the form x squared plus bx cannot be factored, you can add a term to form a perfect square trinomial, and this is called completing the square. And what you do is here's the x squared term, and here's x to the first term, or x to the first power, so 6x to the first. You take this value, which is 6, the coefficient, and you divide it by 2 and square it. So divide this by 2 and square it. So that's what you're going to do on the example underneath here. And then what happens is this ends up being x squared plus 6x plus 9. And then you can just take the square root of the first term. Now this is a shortcut from what we were doing the other day. You take the square root of the x squared term and the square root of the 9, and you use the first sign, which is addition, and then you just say x plus 3 squared. Now the other day you had to find factors of 1 times 9, so factors of 9 that sum to 6, and that will work as well. You would end up with x plus 3 times x plus 3, but this is a shortcut. You've made it a perfect square trinomial, and there's a shortcut to factoring those. So let me just show you that this does work. If we do x plus 3 times x plus 3, and we FOIL that out, we'll get x squared plus 3x plus 3x plus 9, which is x squared plus 6x plus 9. All right, let's do one down here. We have x squared plus 4x, and we want to complete the square. So again, we're going to take the 4, we divide it by 2 and square it. So 4 divided by 2 is 2, square it, it's going to be 4. Okay, so you try that one right next to it. All right, and then when you're finished, just turn it over to the other side, and now we're going to use completing the square to solve quadratic equations. All right, and the steps are listed out over here to the left. So we're starting out with this equation, and it says to collect the variable terms on one side of the equations and the constants on the other. So the constant is already on the other side, so we can move on to the next step. As needed, divide both sides to make the coefficient of the x squared term 1. Okay, so this is really, really important. So I'll just put a star next to that. The x squared term must be 1, or you can't complete the square. All right, so we need to divide everything by 3, and when we do that, we're going to leave a blank here because just like on the other side, we're going to complete the square. So it's going to be x squared minus 8x plus something equals 9 plus something. Now, one of the biggest mistakes that people make when completing the square is forgetting to add to both sides. Whatever you do to one side of an equation, you have to do to the other side. All right, now we're going to take this value, and it's a negative 8 for our coefficient. So we're going to divide negative 8 by 2, which will give us negative 4, and then we're going to square it. So that's going to give us 16 here and 16 here. All right, now what we're going to do, we're going to factor this as a perfect square trinomial. So I take the square root of this and the square root of this, and always take the first sign. So that's going to come down here. And when we do that, we can just say that this is x minus 4, and it's going to equal 25. Let me cover this up a little bit here. That's the other half of the problem. All right, once you do that, then you take the square root of both sides, step number 5, so square root of this entire side, and squaring a number, or taking the square root of an expression that's squared, undoes the squaring. So that's going to give us x minus 4 is plus or minus 5. Now, you're not going to leave it like that. You're going to break that up into 2 problems. X minus 4 equals 5 and x minus 4 equals negative 5. And then just solve each individual one by adding 4 to each side. And you have x equals 9 and x equals negative 1. Now you could always check this by substituting 9 back into here, and you should get 27. And substituting negative 1 back into here, and again you should get 27. And that's an easy one to see. Negative 1 squared is 1. That makes that 3. So 3, and put a negative 1 in there, it's going to make that plus 24. So 3 plus 24 is 27. And again, the same thing will be true for the 9. Now, you can use completing the square to change a quadratic equation from standard form into vertex form. Okay, you're going to repeat steps 1 through 4 above, and again, you need to make sure that you divide both sides to make the coefficient of the x squared term a 1. Now, it's going to be a little bit different here if our coefficient isn't 1, and I'll go over that tomorrow. But for right now, we're just going to have a problem that has a coefficient of 1, and what we're going to do is we're going to move the constant over to the other side, just like we did in the example above. We're going to take 24, divide it by 2, and square it to fill in or complete the square. So 24 divided by 2 is 12, and then we're going to square that to give us 144, and that has to be added to both sides. All right. So added to here, added to here. So let's just put the 144 up here. Maybe it'll be easier to see what we're doing here. So divided by 2, square 144 in both blanks. Okay, now what we're going to do is we're going to factor the variable expression as a perfect square. So we're going to take the square root of this. So the square root of the x squared term, square root of the constant. So it's going to look like this. And when we take the square root of both of those, we're going to use this sign. So with square root of x squared is x. The square root of 144 is 12. And then we just keep this sign. Now a lot of times people will say, well, where does that 24 go? The 24x. If you FOIL that back out, just like I showed you on the other side here, you may want to know, well, where did the 6x go? It's still there because when you multiply these two binomials out and FOIL them, you're going to get your 6x back there. So you just don't see it. It's not but when you FOIL it back out, it's going to be there. Okay, so we're at this step right here, I believe. And now we're going to, we put these two constants together to get -1. Okay, now we want it in vertex form. So remember, vertex form looks like this. F of x equals a times x minus h squared plus k. So we need to move this value over to the other side. When we're solving it, we take the square root of both sides and solve, but we want to be in vertex form. So what we're going to do now is just move this over to the other side, and now we have vertex form, and we can tell what the vertex is. The vertex is -12, +1, which is the same thing you would get if you did -b over 2a. And then so -b over 2a would be -24 over 2 times 1, and then you would plug that -12 back in here, and you'll end up getting a 1. So that's the vertex form, going from standard to vertex, and this is what your vertex form would look like. I just wrote it back over here. And tomorrow I'll talk to you about what happens if the coefficient of the x squared term, or a, is not 1. That makes it a little bit different. Okay, there's 2 questions for you to try.